China's newest aircraft carrier, the 80,000-ton Fujian, is now underway. It is the first vessel built outside the United States to utilize electromagnetic catapults, ending a long-standing American monopoly on this specific launch technology. Welcome back. The question we are looking at today is straightforward. Does China's newest flagship actually rival an American supercarrier? Before we break down the hardware, make sure to hit subscribe and join our community of strategic thinkers. With the commissioning of the Fujian, the People's Liberation Army Navy has officially transitioned into a 3-carrier force. At an estimated 85,000 tons of full load displacement, the Fujian holds the title of the largest non-nuclear warship currently operating anywhere in the world. But possessing advanced specifications on paper does not automatically equal operational dominance on the water. To find out who holds the true strategic advantage, we are going to evaluate the Fujian directly against the U.S. Navy's USS Gerald R across 4 precise metrics. Our first evaluation point focuses on what actually moves these floating cities: power and propulsion. The Fujian relies on conventional propulsion. Deep inside its hull, it uses a system of 8 high-pressure boilers feeding 4 steam turbines. The USS Gerald R is driven by 2 advanced A-1B nuclear reactors, generating massive surpluses of electrical energy. This horizontal bar chart compares the fuel endurance metrics of the 2 ships. Looking at the top bar, you can see the Fujian's conventional setup yields 30 knots of speed, but limits the ship to roughly 15 to 18 days of in-theater operations before its fuel bunkers run dry. Now look at the bottom bar. The Ford's nuclear reactors require no fossil fuel refills, giving the American ship a continuous operational lifespan of 20 to 25 years before its first reactor overhaul. Because of its conventional engines, the Fujian is tethered to a chain of slow-moving oiler ships. In a conflict, these tankers represent vulnerable targets that can be picked off by submarines or long-range missiles. Those logistics restrict China's carrier to regional operations within the Western Pacific. Without the need for constant refueling, the United States maintains its ability to operate across entire oceans for months at a time. Our second evaluation point looks at how these ships put aircraft into the sky: launch technology. Both navies have replaced maintenance-heavy steam catapults with electromagnetic aircraft launch systems, or EMALS. To power these magnets, the engineers took different paths. The Fujian uses a medium-voltage direct current architecture, while the Ford utilizes an alternating current system. Regardless of the electrical architecture, the physical outcome is the same. Both carriers can smoothly accelerate heavier, fully armed aircraft down the deck, with far less mechanical stress on the airframes than previous generation carriers. But the hardware numbers favor the Americans. The Fujian is equipped with 3 catapults, compared to the Ford's 4. More importantly, the Fujian has to rely on conventional boilers to charge the capacitors that power these electromagnetic systems between launches. China's direct current system is stated to be highly reliable, but without the power surplus of a nuclear reactor, the Fujian will struggle to deliver the same sustained energy per launch as the Ford during high-tempo combat periods.
The third metric examines the physical space where those launches happen, deck layout, and sortie rates. Because the Fujian burns fossil fuels, it requires large internal exhaust funnels. Those lines dictate that the island superstructure sit closer to the center of the flight deck. This blueprint of the Fujian's flight deck shows the consequence. Because of that island placement, the waste catapult track physically intersects with the angled landing runway. Aircraft returning from a mission must wait to land while others take off. This geometry prevents Propulsion from launching and recovering aircraft simultaneously. On the USS Gerald R. the island is pushed much further aft. This highly optimized deck geometry allows for uninterrupted simultaneous launch and recovery operations. That physical interference has a direct mathematical consequence. Defense analysts calculate that the Fujian operates at roughly 60% of the operational tempo of a Nimitz-class American carrier. A carrier's combat value is defined by its sortie rate, how fast it can put weapons in the air. By avoiding deck bottlenecks, the Ford can surge to 160 sorties per day, while the Fujian's layout remains its primary operational constraint. Our final point of evaluation is what actually flies off those decks, the Airwing. With its new catapults, the Fujian is designed to launch heavy J-15T fighters and the newly integrated twin-engine J-35 stealth fighter. The Ford counters with an established mix of Fa-18 Super Hornets and its own fifth-generation asset, the F-35C stealth fighter. For China, the J-35 provides a sea-based fifth-generation capability for the first time. The PLA Navy can now launch aircraft designed to penetrate advanced air defense networks directly from its own decks. However, the U.S. Navy has decades of real-world experience networking stealth airwings with carrier sensor grids. The Ford's dual-band radar allows for simultaneous target tracking and fire control that is already battle-tested. While China's new platforms narrow the technical gap, their unproven maritime integration makes them less certain in a complex conflict than the established systems of American naval aviation. The Fujian is the result of China's leapfrog strategy, skipping generations of steam technology to integrate electromagnetic catapults onto a clean sheet design. It serves as a proof of concept for a domestic shipbuilding industry that can now produce high-tonnage, flat-deck carriers. Within its specific operational scope, it is an effective regional enabler. If a conflict remains close to home, inside the first island chain, the Fujian provides stealth capability and air superiority that the U.S. Navy must take seriously. On a quadrant chart measuring endurance against combat tempo, the Fujian plots in the middle. Its reach is tethered to oilers and tempo slowed by deck layout. The Ford populates the extreme top right, achieving maximum reach and high tempo through a bottleneck-free design. When a mission requires high-tempo power projection far from home ports, the USS Gerald R. Ford remains the superior platform. Thank you for watching. If you found this breakdown helpful, please like, share, and subscribe to the Global Warwatch Network. Let us know how you evaluate these two massive ships in the comments below.